What is going on, wonderful people? It's Medicosis Perfectionalis, where medicine, chemistry, and physics make perfect sense. Welcome back to my MCAT physics playlist. And since the MCAT does not allow a calculator on the exam as of this moment, therefore, sorry to break this to you, but you gotta use your brain. Lucky for you, there are some nice tips and tricks that will make your life easier. In this video, we'll talk about algebra, trigonometry, geometry. We'll talk about fractions, decimals, exponents, bases, powers, logarithms, degrees versus radians, and much more. So click the like button, click the subscribe button, and let's get started. This video is part of my physics playlist. Please watch these videos in order. This playlist has a video on every single topic required for physics for the MCAT or DAT exam. This video was only possible because of Dylan's generous support. He supported my channel and requested a video on math, so please take a moment to say thank you to Dylan in the comments. If you want me to create special videos for you, reach out to me on my website medicosisperfectionalis.com. Let's start by reviewing some arithmetics: multiplication, division, addition, subtraction, etc. Starting with significant figures. Can you please round this number to 3 significant figures? Okay, so here's the first, the second, and the third, which means I can write this as 5, 6, 5, and then these are 3 significant figures. I'm done. But do you think 565 is the same as 565 212? No, this is 500, this is 500,000. They are not the same. They are not in the same place. So therefore, I need to add my 3 zeros like this. Oh, now it makes sense. And still, this whole number has only 3 significant figures, because zeros on the right are non-significant. How about this? 565723, rounded to 3 significant figures. So you might say 565000, but that's not true, because after the 5 there is a 7. So you round up just like this, and this is the final answer. Next, we need to round this decimal number to 1 significant figure, 2 significant figures, 3 significant figures, 4 significant, etc., etc. So let's start. 1 significant figure, okay? So you put the decimal point, okay, then what? Then there is 0, all right? So far, I do not have any significant figures. Let me add the first one, which is 1. So this is 0.01. Since the 1 is followed by the 2, I'm not going to round up. So it's going to stay 1, and it's not going to become 2. And this is the answer if you want 1 significant figure. How about 2 significant figures? Easy. Take the next one. After the 1, what do you have? You have 2. And after the 2, there's 3. So I'm not going to round up. And this is my answer if you want 2 significant figures. What if I want 3 significant figures? Okay, 0.0 so far, no significant figures. And here's 1, 2, 3 significant figures. 4 significant figures, please. Easy peasy. 0.01, 2, 3, 4. And the 4 significant figures here are the 1, the 2, the 3, and the 4. 5 significant figures. 0.01, 2, 3, 4, 5. What if I want 6 significant figures? Easy. You write the previous number, 1, 2, 3, 4, 5, and then you add a 0. Oh, but the 0 on the right is not significant unless there is a decimal point. If there is a decimal point, anything you write after the decimal point will be significant, including the 0. Let's make it into 7 significant figures, 0.0, 1, 2, 3, 4, 5, 0, and another 0. Next, the subject of scientific notation. For example, if I write 0.05, yes, this is a number, but it's not in the proper scientific notation. How can I write it in the proper scientific notation? To write it in the proper scientific notation, you have to give me something that is between 1 and 10. So I'm going to write a 5. Just like this. How can I go from 5 to 0.05? If I divide the 5 by 100, I'll get 0.05. Because when you divide by 100, what do you do? Well, every number has its own hidden decimal after it. So you go backwards 2 times like this, and you write a 0. The decimal point will be here, and don't forget that 0. So it's 0.05, exactly correct. How did I did this? By dividing by 100. Dividing by 100, meaning I'm dividing by 10 power 2. Dividing by 10 power 2 is like multiplying by 10 power negative 2. Because when you multiply by 10 power negative 2, it means that you're multiplying by 1 over 10 power 2, which means 1 over 100, which means you're dividing by 100. So this is the proper scientific notation. How come? Because this number is between 1 and 10, and then you multiply by the 10 is your base, and then you write whatever exponent it is. So the scientific notation should look like this. Your m has to be between 1 and 10. And then you multiply that by 10 and give me a lovely exponent. Could be a positive exponent or a negative exponent. M has to be between 1 and 10, but the base has to be 10. When I write the number like this with a hyphen or a bar above 0, it means that this is significant, but after that, not significant. So in this number, how many significant figures? 1, 2, 3, 4, 5 significant figures. You can write the same number like this, and you tell me that it only has 5 significant figures. What if I want this number in the proper scientific notation? Okay, so it has to be written like this. M times 10 power x. The m has to be between 1 and 10. How can I change this number to something between 1 and 10? How about 1.2? Oh, that's between 1 and 10. So how can I change this number to 1.2? Look at the decimal point. The decimal point was here. See how many times we have to go backwards. Here is 1, 2, 3, 4, 5, 6. So that the decimal point is here, which means you multiply this by 10 power 6. Because when you take 1.234 multiplied by 1,000,000, it means that you have to be shifted forwards 6 times. 1, 2, 3, 4, 5, 6. How about this number, 3,500? Can you write it in the proper scientific notation? Sure. What do you want? I want something between 1 and 10. How about 3.5? Oh, that makes sense. How can I take the 3.5 and make it into this number? The decimal point has to be shifted once, twice, 3 times, so that it becomes something like this. When you shift the decimal point forwards 3 times, it means that you multiplied by 10 power 3, and this is your answer. Let's try this, 0.045. Can you write this one in the proper scientific notation? Sure. Between 1 and 10, there is 4.5. Okay. How can I make this number reach this number? If you take the decimal point and you shift it backwards once and twice. Shifting backwards twice is 10 power negative 2. Notice the difference between shifting forwards to become like this and shifting backwards to become like this. Next, fractions. For the MCAT, you need to know that 1 over 1 equals 1. I mean, at your age, if you did not know this already, there is no hope for you. I'm joking. How about 1 over 2? This is 0.5. 1 over 3, a third, is 0.3333, etc. 1 over 4 is 0.25. 1 over 5 is 0.2. 1 over 6 is 0.166666. 1 over 7 is 0.14. 1 over 8 is 0.125. And 1 over 9 is 0.11. And 1 over 10 is 0.1. Let's say that you know that 1 over 10 is 0.1, which makes sense because 1 over 10 is 1 divided by 10. So you take the decimal point and you go back once, it becomes 0.1. So I know that 1 over 10 is 0.1, but I do not know 1 over 9. Well, the numerator stayed the same, but the denominator decreased. When the denominator decreases, the entire ratio has to increase, which means 1 over 9 has to be slightly greater than 0.1, like this, 0.11111. How about this? 1 over 4 is 0.25. How can I get it without a calculator if I did not memorize it? Okay, try to make the denominator 100 to keep it easy, okay? 4 times what equals 100? Well, I need to multiply this 4 by 25 to make it 100. If you multiply the denominator by 25, you have to multiply the numerator by 25. So therefore, the denominator is now 100 and the numerator is 25. 25 divided by 100 is what? Move the decimal point twice backwards. Here is 1, here is 2. So it is 0.25, and this is the answer. Of course, you know that 1/8 is half of 1/4. If you take 0.125 and multiply it by 2, you get 0.25. Please pause and try to answer these yourself without a calculator. 1 divided by 100, here is the 1, the decimal point is here. I need to go backwards twice, 1 and 2 will give me 0.01. which is 1 in 100. How about 1 in 1,000? Well, 1 in 1,000 will be this, 0.001. That's 1 in 1,000. How about 1 over 10? We just said that. 1 over 10 is 0.1. Let's make it 1 over 10,000. It will be 0.0001. Can you write 0.0001 in the proper scientific notation? Sure. I need something between 1 and 10, so that's the 1. And then you multiply this by 10 power what? Well, I want the 1 to go backwards and become this. So here is 1 shift of the decimal point backwards. Here is 2, 3, 4 backwards. So it's 1 times 10 power negative 4. And by the way, anytime you have an exponent that's negative, it means that it's 1 times 1 over 10 power 4, which means it's 1 multiplied by 1 in 10,000 like this, which equals 1 over 10,000, which was the thing that we started with in the first place. Next, 3 over 2 is 1.5, so it's 1.5. Let's say that you do not know that 3 over 2 equals 1.5. Easy. 3 over 2 is what? It is 2 over 2 plus 1 over 2. Remember, when you have common denominator, when you have the same denominator, you can just add the numerators. The denominator is 2. Numerators, 1 plus 2 equals 3. Okay, now it's easy. 2 over 2 is 1, and 1 over 2 is half. 1 plus half equals 1.5. Let's try this. 7 over 5. 7 over 5 equals 5 over 5 plus 2 over 5 equals 5 over 5 is 1. 2 over 5, okay, I do not know. Make the denominator 10 or 100. Let's make it 10. 5 multiplied by what will give you 10? It's 5 multiplied by 2. Therefore, you have to multiply the numerator by 2 as well. 2 times 2 is 4. 4 divided by 10 is 0.4. So it's 1 plus 0.4, which is 1.4. So 7 over 5 looks scary, but it's simply 1.4. Next, 2 plus 1 over 3 plus 4 over 6. Oh, you can realize that this is a third, and 4 over 6, if you simplify, divide by 2 is 2, divide by 2 is 3. So it's 1 over 3 plus 2 over 3. That's just 1 plus 2 equals 3. Let's say that you do not want to do it this way. Easy. Create a common denominator. I have 1 as a denominator under the 2. I have a 3 here and a 6 there. Let's create a common denominator that is going to be divisible by 6, 3, and 1. So let's choose 6. Okay, 6 divided by 1 is what? 6 divided by 1 is 6. Times 2 is 12. Okay, and then you do the same thing for the next one. 6 divided by 3 is 2. Times 1 is 2. And then you do the same thing for the third one. 6 divided by 6 is 1. Times 4 is 4. So the denominator is 6 and the numerator is 12 plus 2 is 14 plus 4 is 18. 18 divided by 6 is 3. It's the same answer once again. Because in mathematics, all roads lead to Rome. Arithmetic is my Roman Empire. Next, let's practice some multiplication. Let's start with something easy. How about 5 times 25? Okay, how can you multiply 5 by 25? Well, let's reverse this just to make the number underneath smaller or having less digits than the number above it. 5 times 5, like this, is 25. Here is 5 and here is 2. 5 times 2 is 10, plus 2 is 12. Let's say that you do not have time to do this. Okay, 25 times 5 is like what? It is like 20 plus 5 times 5. Amazing. What is 5 times 20? Oh, that's 100. And what is 5 times 5? It is 25. 100 plus 25 is 125. How about 24 times 12? Easy. 24 is what? It is 20 plus 4. 12 times 20 is 240. Plus 12 times 4 is 48. 240 plus 48 is 288. There you go. Now let me tell you about a great mathematical trick that I've discovered on my own when I was young and innocent. It only works if you're multiplying a number by itself. And the units digit is 5. Okay, how can I multiply this? Well, this is what you do. Here is 5, you multiply that by 5. 5 times 5 is 25. And look at this, what do I have in the tens? I have 1. 1 times 1 plus 1 equals 2. There you go. Does that work for anything? Absolutely. Let's try 25 times 25. 5 times 5 is 25. Write that to the right. 2 times 2 plus 2. 2 times 2 is 4 plus 2 is 6. 625 is the answer. Oh, is that right? 35 times 35. Let's go. 5 times 5 is 25. 3 times 3 is 9. Plus 3 is 12. There you go. Let's do something crazy like 55 times 55. 5 times 5 is 25. Then 5 times 5 plus 5. 5 times 5 is 25 plus 5 is 30. Did your math teacher tell you about this? I bet he didn't, and that's why you need a medicosis in your life. If you multiply by 10, you move the decimal point to the right once. How about this? Oh, this is just 10 repeated again. So it's 10 power 2. Look at the exponent. The exponent in the first one was 1. That's why I'm going to shift to the right once. But the exponent here above the 10 is 2. So you're going to shift this twice, like this. How about 3.9 times 1,000? 1,000 is 10 power 3. So I'm going to shift the decimal point 3 times to the right, and it's going to look like this. And this is the same as this, so the answer is the same. Shift the decimal point to the right 3 times. So here's 1, 2, and 3. Let's talk about division. 3.9 divided by a 10. When you divide by a 10, it's as if you're multiplying by 10 power negative 1. And when the exponent is negative, or when you're dividing by 10, you shift the decimal backwards to the left. And this is going to become 0.39 because I took that decimal and I shifted that to the left only once. How about this? Divided by 100 is like multiplying by 10 power negative 2. Shift the decimal point to the left twice. It becomes 0.039. 3.9 divided by 1,000. It's as if I'm multiplying by 10 power negative 3. So shift to the left 3 times. It becomes 0.0039. How about this? Divided by 10 power 2. We just shift the decimal point to the left twice. It becomes 0.039. The decimal point was here. I shifted that backwards twice. Next, some words of wisdom. It is better to be approximately right than precisely wrong. So, on your MCAT exam, acceleration caused by gravity is 9.8 or 9.81. But if you make it to 10, if you round it up to 10, no big deal. It's close enough. As for Avogadro's number, you can just approximate it to 6 times 10 power 23 instead of all of this nonsense. Okay, please try to solve these 3 problems. Pause. 5 times 85. This is 5 times 80 plus 5 times 5. 5 times 80 is 400 plus 5 times 5 is 25. This will give me 425. Next, 0.78 times 1,000. You shift the decimal point to the right 3 times. 1, 2, and 3, so it becomes 780. The decimal was here. 1, 2, 3. There you go. How about 513.9 divided by 10 power 6? I need to shift to the left 6 times. So let's shift backwards. Here's 1, 2, 3, 4, 5, 6. So the answer is 0.000539. Next, how about something like this? Well, let's approximate. It's better to be approximately right than precisely wrong. 0.099 is almost 0.1. Multiply that by 211. When you multiply something by 0.1, it's as if you're multiplying it by 1 over 10, which means you are dividing it by 10. And just like that, the answer will be 21.1. This is the approximated answer. If you want the actual answer, it's 20.889, which is very close. The following tricks are so important. If I say that A over D equals C over B, can I perform cross multiplication? Sure. So that's A times B equals C times D. Let me write this down. A times B equals C times D. How can I rearrange this to say A over C equals something? So you want A over C. If you want A over C, take that D when you're coming back over the B. So it is A over C equals D over B, just like this. What if I wanted A over D? If you want A over D, you're going this way. Bring the C with you when you're coming back over B. Just like this, and believe it or not, this equation is the same as the original equation. Then I want you to manipulate the equation to say A equals something, B equals something, C equals something, and D equals something. I shall answer all of these twice, the first time using this equation and the second time using that equation. A equals what? If you want A alone, you need to divide each side of the equation by B so that you can cancel B with B and only A will result. And since I divided by B on the left, I have to divide by B on the right. So A equals CD divided by B. Let me do the same thing for B. If you want B alone on one side, you need to divide each side of the equation by A. So we can cancel A by A here. And the remainder is B. And this one is CD divided by A. Next, I want C alone. If you want C alone, you need to divide each side of the equation by D. Cancel D with D. C equals AB divided by D. Here is AB divided by D. Last, we have D alone. If you want D alone, divide each side of the equation by C. C goes with C, and you have AB divided by C as the final answer. Now, let me answer all of them again using the second equation. Look at this. A over D equals C over B. If I want A alone, what should I do? Well, if you want A alone, look at the following zigzag action. Across, you go C times D, and then you go back divided by B. Remember, this is cross multiplication. When you go diagonally across the equal sign, you have to multiply. This is C times D divided by B, which is exactly what we got from the previous attempt. Next, how about B equals? If you want B alone, look at the following zigzag action. It has to be C times D divided by A. Or you can go this way, D times C divided by A. So it is D times C divided by A. Same exact answer as we got from the previous equation. What if I want C alone? If you want C alone, it has to be A times B divided by D. Just like that. What if I want D alone? If you want D alone, it's gonna be A times B divided by C. Just like this. And that's how you do it. Next, how can you solve this? Well, there is a lovely trick that goes like this. If you have A multiplied by B, A multiplied by B equals A times 100 multiplied by B divided by 100. You can cancel the 100 with the 100, so the end result is A times B. You can do the exact same trick here. 0.05. Oh, if I can just multiply this by 100, I can get rid of the decimal and it will become just 5. But in order for me to multiply one of them by 100, you gotta divide the other by 100. So it's 200 divided by 100. 100 multiplied by 0.05 is 5. Multiplied by 200 divided by 100 is 2. 5 times 2 is 10. And that's how you do it. What if you are mathematically sophisticated and you recognize that 0.05 as 1 over 20, which is correct. 1 over 20 multiplied by 200 is like 200 divided by 20, which is just 10. Because this is 5 in 100. 5 divided by 100, which is 1 over 20. 0.5 is half. 0.05 is 1 over 20. 0.005 is 1 over 200. If you cannot do it quickly in your head, go like this. 0.005 equals 5 in 1,000, just like that. Divide by 5 up and down. 5 divided by 5 is 1. 1,000 divided by 5 is 200. How about this multiplication? I can use the same trick. I'm gonna multiply this side by 1,000 and divide this side by 1,000. 0.007 times 1,000 is 7. 3,000 divided by 1,000 is 3. 7 times 3 is 21. Square roots. Don't forget, when you have x under square root like this, this is the exact same thing as x power half. So the square root of x is the same as x power half. How about the cubic root of x? It is x power third. How about something like this? Oh, this will equal x power fourth. What's the square root of 4? Ask yourself, what times what number, if multiplied by itself, will give me 4? It is 2 times 2. The square root of 2 times 2, you just take one of these and the answer is 2. How about 16? Oh, right, the number that multiplied by itself yielding 16 is 4. 4 times 4 is 16. Pick one of these, and that's 4. How about the square root of 9? 9 is 3 times 3. Pick one of them, and that's 3. How about something like this? Well, remember, the square root can be removed and replaced by an exponent of half. And when you have an exponent raised to another exponent, you can just multiply them. 6 times half. Half of the 6 is 3. So this answer is x power 3. How about this nonsense right here? Okay, we'll keep the square root as is. What's under the square root? Oh, I have a base of 10. And because we're multiplying, I'm going to add the exponents. 2 plus negative 8 is 2 minus 8, or negative 6. How can I get rid of the square root? If you replace it with an exponent of 1/2. So this is 10 power negative 6, all power half. When the exponent is raised to another exponent, multiply them. What is half of negative 6? It is negative 3. So the final answer here is 1 over 1,000, or 0.001. Can you solve this? Please pause. Oh, that's easy. I can do it. So, what is 48? I want to simplify this into a number whose square root is known. I know that 48 is 16 times 3, because I know that the square root of 16 is 4. Amazing. Minus 27 is 9 times 3, because I know that the square root of 9 is 3. And therefore, this becomes square root of 16 times square root of 3 minus square root of 9 minus square root of 3. What's the square root of 16? It is 4 square root 3 minus the square root of 9 is 3 square root 3. 4x minus 3x is just 1x. So it is square root 3, which is about 1.7. How about this one? Can you do it? Yeah, the square root of 45 is what? That's 9 times 5. And 20 is 4 times 5, because I know that the square root of 9 is 3 and the square root of 4 is 2. I can get the 9 out of the square root because the square root of 9 is 3, square root of 5, minus the square root of 4 is 2, square root of 5. 3 square root 5 minus 2 square root 5 is just 1 square root 5. Can you convert this number to decimal? I cannot do it without a calculator. But let's try together. Square root of 5 has to be slightly greater than the square root of 4. What's the square root of 4? Oh, that's easy. That's 2, because 2 times 2 is 4. So therefore, the square root of 5 is a little more than 2. It's actually 2.2. See? It's easy when you understand what the flip you're talking about. If you want to mathematically roast your buddy, just tell him that his achievements are like the square root of a negative number. Imaginary. This is unreal. Unreal is what my calculator said when I plugged in a square root of a negative. Next, exponents, i.e. powers, as in 1 times 10 power 5. This is the base, this is the exponent. And this 100,000 is the result. 50 times 10 power 2 is 5 times 10 power what? Please pause. Well, here's the thing. Look at the 50 when it became 5. We divided it by 10. If you divide this by 10, you have to multiply that by 10 to compensate for it. So therefore, the 50 became 5 when we divided by 10. This 10 power 2 will become what when you multiply it by 10? You simply add the exponents. It becomes 10 power 3, which means x equals 3. Next, 0.5 times 10 power 2 equals 5 times 10 power what? For the 0.5 to be 5, we multiplied that by 10, which means you have to divide this one by 10 to make up for it. 10 power 2 divide by 10, you subtract the exponents. 2 minus 1 is just 10 power 1, so x equals 1. Next, for the 0.005 to become 5, we multiplied this by 1, 2, 3. And just remember that when the 0.005 is written alone like this, there is a hidden 10 power 0 next to it. 10 power 0 is 1. Okay. So, when I took the 0.005 and make it into 5, what did I do? I multiplied this by 1,000. To make up for it, I need to divide this by 1,000. So divide by 10 power 3. Subtract the exponents. 0 minus 3 is negative 3. So x here is negative 3. Some rules for the exponents. If you have a times 10 power x plus b multiplied by the same base and the same exponent, you can simply add a to b, a plus b, multiply the result by the same base and the same exponent. But that is true if this is an addition. But what if everything here is multiplication? A times 10 power x times, not plus, but times, b times 10 power y. You have to multiply a by b like this, and then you multiply what? The base remains 10, but you have to add the exponents like this. Let's practice what we preach. Oh, look at this. It's the same base and the same exponent here and here, which means the end result has to be multiplied by the same base and the same exponents. You simply add 1.7 plus 1.3. This is ironically 3, and that's my final answer. It is 300. How about this? Oh, that's multiplication, which means 5 times 2 is 10. Multiply this by 10 power 3 times 10 power 2. The base is 10. The exponent is 3 plus 2 equals 5, and this will give me 1,000,000. Scientific notation, 1 times 10 power 6. Next, how about this? Oh, it's the same. Oh, it's not the same base. There is addition, but it's not the same base. Therefore, I have to manipulate this side or that side so that the exponents are the same, so that I'll be able to add. Let me manipulate this side. I want this to become 10 power negative 2. When the negative 3 in the exponent becomes negative 2, what does that mean? It means that this part was multiplied by 10. To make up for it, I need to divide this by 10. So this can become 0.6 multiplied by 10 power negative 2. Same base and exponent here and here. You simply add these two. 4 plus 0.6 equals 4.6 multiplied by the same base and the same exponent, which is the same as 0.046. How about the last one? Okay, subtraction, but do I have the same exponents? No, they're not. So I need to manipulate this or manipulate this. Let me manipulate the left side. Okay, if you want the 10 power negative 3 to become 10 power negative 4, it means that you divided by 10, which means you need to multiply that side by 10 to make up for it. 2 times 10 becomes 20, multiplied by the new one is 10 power negative 4. Now I have the same base and exponent, same base and exponents. You write this down like a champ. 20 minus 1 is 19. So it's 19 times 10 power negative 4. Can you convert this to the proper scientific notation? Let me know the answer in the comments, and please call your answer question number 1. Next, multiply this by this and report your result in the appropriate scientific notation. Please pause. How can we do this? Okay, it's all multiplication, so it's 3.5 times 5. 5 times 3 is 15. 5 times 1/2 is 2.5. 15 plus 2.5 is 17.5. Multiplied by the base is 10, and you add the exponents just like this. Is this the proper scientific notation? I will be damned if it is, because this number is greater than 10. This has to be between 1 and 10. Which means I need to shift this decimal point backwards by dividing this side by 10, so that it becomes 1.75. If I divide this by 10, I have to make up for it by multiplying this by 10, so it becomes 10 power 6. Now this is proper scientific notation. There is good, there is evil, there is north, there is south, there is east, there is west. There is yin, there is yang. There are exponents, and there are logarithms. Look at this. Where is the base of the log? Oh, well, it's not written. If it's not written, we imply that it is 10. And to answer this, rearrange this to make it into exponents. Look at the base and write the base like this. 10 power x, x becomes the exponent like this, equals whatever is in front of the log goes here. Now ask yourself this very basic question, no pun intended. 10 power what will give you 10? 1, of course. So x equals 1. Bingo. How about here? Oh, what's the base? It's not written, so it is implied that it's 10. Okay? So therefore, I can rearrange this into 10 raised to the exponent of y equals whatever is in front of the log, 100. Ask yourself this simple question. 10 power what is 100? Oh, the y here has to be 2. Precisely. Next, the base is not written, so it's implied that it's 10. Raise it to the power of z, which will give you 1,000. 1,000 is 10 power 3, which means that z has to equal 3. Easy peasy. Next, what's the value of L if negative log 10 power 7 equals L? Well. Do you see that negative right here? It's gonna confuse me. So I'm just gonna shift it to the other side. If negative log 10 power 7 is L, then log 10 power 7 without the negative equals negative L. Amazing. What's the base? Not written, so it's implied as 10. Therefore, 10 power negative L equals whatever was written in front of the log. Therefore, negative L equals 7, and therefore L equals negative 7. Now, here is a question for you. Please comment your answer below and label it answer number 2. What is negative log of 1? Let me know your answer down below in the comments. Next, why do we care about logarithms so much? Because of the pH, that's for starters. Remember that the pH is the negative log of the hydrogen ion concentration, which means if the hydrogen ion concentration in a solution is 1 times 10 power negative 7 or 0.0000001, if you want the pH, it's the negative log of all of this nonsense, which means that the pH is negative, the logarithm of 10 power negative 7. Keep that negative in mind. We're coming back to it. What's the base? If it's not written, it's implied as 10. 10 power what will give you 10 power negative 7? 10 power what equals 10 power negative 7? Well, that thing has to be negative 7. But don't forget that negative, which means the pH is 7. On your exam, when you see something nonsensical like this as the hydrogen ion concentration, and it's written with a base of 10 and a negative exponent, you just grab the number in the exponent without the negative. Leave the negative alone, just grab that 7. Oh, what if the hydrogen ion concentration is 10 times negative 5? You just grab the 5 on the exponent without the negative, and the pH is 5. That's the simplest trick. So pay attention. If I give you two solutions, solution A has a pH of 7, which is neutral, and solution B has a pH of 5, which is acidic, the novice, mediocre, amateur student will say, oh, solution B is just slightly more acidic than 7. I mean that the hydrogen ion concentration is just slightly higher than A. No, that's not true. Solution B is 100 times more concentrated with H. Look at the difference. Oh, the difference between these two is 100 times. So when it comes to the hydrogen ion concentration, it is 100 times greater in solution B when compared to solution A. That is why we have a log. So when the hydrogen ion concentration of a solution is this, just grab the 7 and that's your pH. If it's like this, grab the 5 without the negative, and the answer here is 5 for the pH. What's the measuring unit for the pH? It does not have a measuring unit. And if you're studying for the MCAT, the following physical quantities do not have a measuring unit. These include the pH, mechanical advantage, specific gravity, Reynolds number, index of refraction, magnification, coefficient of static friction, and the coefficient of kinetic friction. Don't forget that the coefficient of static friction is always greater than the coefficient of kinetic friction. I've talked about all of these concepts in this physics playlist. And because the pH is the negative log of hydrogen ion concentration, therefore, the greater the acidity of the solution, the lower its pH. Radians. For the MCAT, you only need to learn about radians when we talk about the angular frequency. And this topic of angular frequency was discussed in detail in my video on sound waves, which you can find in this playlist. Next, some relations. If I write an equation like this, A equals B over C. it means that the relation between A and B is directly or directly proportional. If B goes up, A goes up. If B goes down, A goes down, provided that C remains constant. If I write it like this, it means that the relation between A and C is inverse. If C goes up, A goes down. If C goes down, A goes up, provided that B remains constant, of course. And if I write it like this, it means that the relation between B and C is direct. If B goes up, C goes up. And if B goes down, C goes down, provided that A remains constant. So the moral of the story is, anytime you have two entities multiplied by one another, remember cross multiplication, they are inversely correlated. But anytime you have two entities divisible by one another, because I can rearrange this equation into this, A divided by B equals 1 divided by C, which means that these two entities, A and B, are divisible by one another. If they are divisible by one another, they are directly correlated. Look at the last one, B over C. B over C are divisible. That's why they are directly correlated. What if I write an equation like this? A plus B equals C. If it's written like this, any two entities that are added to one another are inversely proportional, provided that C remains constant. I mean, think about it. If I say that 4 plus 6 equals 10, we're gonna keep that 10 constant, okay? If this 4 became 5, what do you think has to happen to the 6 so that 10 remains constant? Oh, 6 has to decrease and become 5. So as A goes up, B has to go down as long as C remains constant. What if the two entities are subtractable from one another? For example, I can say that A minus C equals negative B. Look at this. They are subtractable from one another. If they are subtractable, it means they are directly correlated. How about B and C? Also subtractable because I can bring B with the negative sign to the other side. If they are subtractable, they are directly correlated, provided that A remains constant. Which means any two entities divisible by one another or subtractable from one another are directly correlated, provided that everything else remains constant. But when the two entities are multipliable by one another or can be added to one another, they are inversely correlated, provided that everything else remains constant. Next, graphs and slopes. How to read graphs? Well, you first have to look at whatever is on the y-axis and whatever is on the x-axis. If you get these entities wrong, you will answer everything incorrectly. You have to know the relation. It's a relation between x and y. Okay, if the graph looks something beautiful like this, going up, this is directly correlated, which means as x goes up, y goes up. But what if the graph is drawn in a different way? Here is y, here is x, but look at the line. It's not going up, but it started up and is going down. This started down and going up, but this started up and going down as time passes by. So this means that the relation between x and y is inverse. Look at this. Between A and B, we have direct correlation. As B goes up, A goes up, and vice versa, which means the slope of this line is a positive number. But look at this. Oh, this is decreasing, which means y is inversely correlated with x, and the slope of the red line will be a negative number. If you're not convinced, just imagine any random numbers. Let's say that this is 5 and this is 10. Let's say that this is 2 and this is 4. And then you calculate the slope, which is rise over run. What's the rise? 5. The difference between this point and this point is 5. What is run? Oh, 4 minus 2 is 2. So it's 5 divided by 2. That's positive 2.5. That's a positive slope. But if I do the same thing here, let's say that this is 10 and this is 5. Let's make this 2 and this 4. If you want the rise or the change on the y-axis, remember that I started 10 and ended 5. So it's 5 minus 10. Oh, that's a negative in the numerator, but the denominator is positive 2. So the slope is a negative number, as you see. When I say rise, I mean the change on the y-axis, which means y2 minus y1. But on this side, it was y2 minus y1. The slope of any of these lines is rise over run. It's the change of the vertical axis divided by the change on the horizontal axis. It's the delta y, which means y2 minus y1 over x2 minus x1. The slope of this line is also tan theta. What is theta? theta is the angle that this line makes with the horizontal. So for B, theta is all of this angle right here between this and this. But for line A, the slope is tan of this theta. It's the angle that the line makes with the horizontal. Remember that tan 0 is 0 and tan 45 is 1. As your angle increases from 0 to 90, the tan of that angle also increases. So A has the smallest angle and therefore the smallest tan theta and therefore the smallest slope. B has a greater theta and therefore a greater tan theta and therefore a greater slope than A. As for C, it has the most humongous angle that you can imagine, which means its theta is huge and its tan theta is the biggest and its slope is the greatest. If you want more math tips and tricks for the MCAT, please watch video number 1, 2, 3, and 4 in this physics playlist, where we talk about more slopes, Pythagorean triples, and all kinds of trigonometry, sine, cosine, and tan. And here are more questions for you. Here is question number 3, and here is question number 4. Pause the video and let me know your answers to these 4 questions in the comments. And because I love you so much, tell me, how many half-lives does it take for the isotope that is radioactive to decrease from 100% to 12.5%? Please answer below in the comments. You can download all of my physics PDF notes with more than 250 problems with their answers at medicosisperfectionalis.com. I help you learn, understand, and pass exams. I have notes for biochemistry, organic chemistry, and general chemistry as well. Plus biology, physiology, anatomy. We got all kinds of notes on my website. And don't forget to check out my other playlists as well. If you found these videos to be helpful, please consider supporting my channel by buying me a coffee. Go to buymeacoffee.com/medicosis. To learn about all of the drama that takes place in your kidney, in the proximal tubule, loop of Henle, distal tubule, etc., download my kidney physiology course on my website. It comes with videos, notes, and cases. And don't forget to say thank you to Dylan in the comments. There are more than 600 premium videos available on this channel when you click the join button and choose the highest tier. Please subscribe, hit the bell, click the join button, support my channel on Patreon, PayPal, or Venmo. Go to my website to download my courses, notes, and cases, or if you would like me to personally tutor you. Be safe, stay happy, study hard, where medicine, math, chemistry, and physics make perfect sense.